Hey everybody, it's Miss A and I am here doing an angles review video. This is a redo of a previous video. I don't know what happened, but my lens, I guess, was foggy, so the video is kind of bad. So I wanted to go ahead and redo this and give you some information and go over what's going to be on the test and some other interesting information if you happen to be watching this video prior to taking the test. All right, so first things that we have to do, sorry about the shakiness, first things we have to do, or the kids have to do, is they have to be able to identify types of angles. So they need to be able to recognize. All right, so they have to be able to identify angle types. So we'll do this first one here. We look at this particular angle. They need to be able to identify that this is an acute angle. They need to be able to identify this is an obtuse angle. They need to be able to identify that this is a right angle, and it won't have that there. That's the international sign for right angle. It won't have that. They need to be able to identify that this is a straight angle. So they have to be able to identify all those. Let me write that here. Acute, obtuse, straight, and right angle. All right, so that's the first thing that they'll have to be able to do. They need to be able to describe these angles. So I know that an acute angle, it measures less than 90 degrees. So less than 90 degrees. I know an obtuse angle measure is greater than 90 degrees. I know a straight angle is equal to 180 degrees. I know a right angle is equal to 90 degrees. So they need to understand the properties of the angles. They need to be able to construct an angle. Construct an angle using a protractor. All right, so let's say that they need to construct an angle that is 37 degrees. So construct an angle that's 37 degrees. Now I have two types of protractors. I know this one's a little bit hard to see, but it has a big hole in the middle, and you place your vertex in this hole. Our zero line is on the edge, and then our arced measurements are on the inside and the outside. So if our angle opens to the right, we use our inside numbers, and if our angle opens to the left, we use our outside numbers. That's very important. And then I have another type of protractor which also has a point where you place the vertex, but this one's slightly different, as the line of 0 and 180 go in the middle of this bar. It's here, and the students have worked with both of these. So I'm going to construct a 37-degree angle with both. So I need to put my vertex here. So I'm going to place my vertex here, and I'm going to do it right on the line. And when I construct an angle, I have to have a ray. And then I place my vertex in this little hole, and I find that I have my protractor upside down first. Then I need to find 37 degrees, and I want it to open to the right, so I'm using my inside numbers here. So that's 10, 20, 30, 35, 36, 37. So I'm going to do it right out here like this. It's a little long, but that's okay. And I connect my vertexes. That's my vertex. And this is a 37-degree angle using this protractor. Now I'm going to do the same thing with this protractor. Make sure, I have it the right way. I'm actually going to open to the left for this one, so I'm going to use my outside numbers. So for this particular one, it has obviously a much bigger hole, and we use the 0 line right there. And I'm looking for 37. That's 35, 36, 37's right there. Here and here. And so you can see that the width of my angles are the same. They'll also have to measure an angle that's already on the test, very similar to this. So I'm going to use this blue one here. So the little hole goes on the vertex, and I line up one of my rays with my 0 line, which here it is. My angle is open to the right, so I'm using the inside numbers. So I'm going to look at my inside set, and I see that this falls between 150 and 140. So I'm going to look, here's 145. It looks like it's about 146 degrees. So they'll also have to be able to do that. All right, let's see what else we will have to know for this test. They will have to be able to add or decompose angles. Decompose angles might be taking an angle and figuring out the total of the angle by using the parts, or figuring out a part by using the total. So let me go ahead and construct an angle here. All right, so let me see. All right, so this is a particular problem of a decomposed angle. It is broken up into two parts. We know the sum and we know one of the parts. So when we're missing, and we call those inside numbers and inside angles and outside angles, we are missing an inside angle. That means we subtract. So I would take my sum, or my total, 128 degrees, and we need to remember to do our degree sign. We don't want to forget that. Minus 35 degrees. 8 minus 5 is 3. Let me put my degree sign so I don't forget. 2 minus 3 I can't do, so I have to regroup. That becomes 12. 12 minus 3 is 9. So A, this big angle here, is equal to 93 degrees. Now they'll also have to be able to do this. Now these numbers will be given to them already. I'm just... All right, here we have an angle, and we have our inside numbers. We're missing our outside angle. So we have to add those pieces together in order to get the sum. So 72 degrees plus 37 degrees equals 109 degrees. So the sum of these two angles is 109 degrees. They will have to be able to read a protractor on paper. And here's a little sneak peek, because this is kind of a different way of seeing it. They will see, I only want to show this one, an angle is shown on a circular protractor. Circular protractor means one that is 360 degrees. What is the measure of the angle? And they want to measure this here. So if it's open to the, and this actually only has one number, one set of numbers. So this, they'll have to read something like that. They need to be able to determine a measurement when there's more than two, so a decomposed angle that has more than two. right, so they have to be able to solve for this angle using this information. So now there should be 4 pieces of information. There should be 3 inside and 1 outside. I have 1 inside, 2 insides. I'm missing an inside, so I know I'm subtracting. My outside is this angle, and the student should know that a straight angle is equal to 180 degrees. So I would take 180 degrees minus 60 degrees, and I'm going to do it in sets. That gives me 120 degrees, minus 105 degrees. Can't do that, have to regroup. 10 minus 5 is 5, 1 minus 0 is 1. So angle A is equal to 15 degrees. They have to be able to solve for that. And let me see here. All right, I'm looking here. All right, so that's the basic gist of this. They will have to be able to figure out angles within a shape. So I know that this whole thing is equal to 90 degrees. If this is 37 degrees, I should be able to figure this out. So they have to be able to do that. Okay, and then the last thing that I wanted to tell you for this video is a little sneak peek as to some stuff that will be on the test. So there are extra credit problems on the test, and I want to give you some ideas. So first thing is you have to understand decimal place value is the extra credit. These are all things that we've previously learned. So if I have 27 hundredths, I know that that is 0.27. You will be subtracting mixed numbers. All right, so 5 and 7/8 minus 3 and 2/8. So remember, we do our smallest units first, which for us are our fractions. So 7/8 minus 2/8 equals 5/8. And then we go to our whole numbers. 5 minus 3 is 2. Now that's just simple, straightforward subtraction. There may be subtraction with regrouping that's needed. 5 and 1/8 minus 3 and 6/8. I can't take 6 from 1, so I have to decompose this into 4 plus 1 plus 1/8, and then I turn this 1 into a fractional whole, so 4 plus 8/8 plus 1/8, and this equals 4 and 9/8 minus 3 and 6/8. So I just have to break this apart to 1 plus something else, whatever it equals. And now I can do this. 9 minus 6 is 3/8. And then 4 minus 3 is 1. So they have to be able to subtract mixed numbers. Oopsie, papers are flying everywhere. Adding fractions of tenths and hundredths. So for example, if I have 5/10 plus 31 hundredths, I know that I cannot add fractions that have different denominators, so I need to create an equivalent fraction with a hundredth denominator. So I'm going to take my 5/10, multiply it by 10 over 10, which equals 50 hundredths, or as I told, add one place value 0 to the top and bottom, plus 31 hundredths, and that equals 81 hundredths. You could also have 3/10 plus 20 hundredths. With this particular one, we can actually make this an equivalent fraction of tenths by taking away a place value 0 in the top and bottom of my 20th hundredths, and that makes 3 plus 2, which equals 5/10. They need to be able to divide. So if I have 476 divided by 8, there were a couple of ways that that they were shown how to divide. We were using friendly numbers or friendly facts. So 1 times 8, it's the ones that I know off the top of my head. I don't need to go in and do all of them. 8 times 10 equals 80. And I know that I could do 8 times 50 would equal 400. Ooh, so that can take out a big chunk. All right, so I'm going to take out 400 first, and that's 8 times 50. And I circle the 50 because that's how many times I used that number 8. When I subtract that, that gives me 76. All right, let me do 40. So that's 8 times 5. Circle the 5. That's how many times I used that number 8. That's 36. Ooh, let me do 16. That's 8 times 2. Circle that 2. That leaves me with 20. 16 again. 8 times 2. That leaves me with 4, which is less than 8. So now how I figure out my quotient is I add all of these together because that's how many times I use that number 8. So that's 50, 55, 57, 59. And my remainder is here. So this is my quotient or my whole groups, and this is my remainder left over. So they need to be familiar with vocabulary of division and able to solve it. Multiplying whole numbers and mixed numbers. So multiply whole numbers and mixed numbers. So 5 times 3 7/8. What I need to do is distribute this 5. All right. They will need to know, oopsie, these are my papers. They will need to know how to multiply whole numbers with mixed numbers. So if I have 5 times 2 1/3, I know that I'm distributing my whole number to both parts of my mixed number. So that's 5 times 2 and 5 times 1/3, which equals 10 5/3. And I know I can't put those together that way because that would be a bad form mixed number. So 5/3 I need to rename as a mixed number. So I take out a whole, fractional whole. That leaves me with 2/3. So 5/3 is equal to 1 2/3 plus 10. Can't forget about my original. So that equals 11 2/3. They'll also need to be able to multiply multi-digit numbers. So if I have 437 times 21, all right, I'm going to show the area model version that we have. So we take each one of our numbers and we break it into place values. So this is 400, this is 30, this is 7, this is 20, and this is 1. 2 times 4 is 8, and there are 3 zeros. 2 times 3 is 6, and there's 1 0. 2 times 7 is 14, and there's 1 0. Oh, nope, there's 2 zeros here. 1, 2. 1 times 400 is 400. 1 times 30 is 30. 1 times 7 is 7. Then you add across. That's 8,740. And then this is 437. And that's 7. Add now. 7, 11. So 9,177. They're also going to have to be able to convert fractions to decimals and decimals to fractions. So if I have 5/10, I know that this has 1 0, so it's one place value after the decimal point, and then I just write my numerator here. Or if I have 0.72, I know that there are 2 place values after the decimal point. That means my denominator has to be 100, and I just write my numerator there. All right. They will also need to be able to, actually, I think that is everything that there is. So this is a little sneak peek as to what's going to be on the test. Hope this video helps. Thanks for watching.